Why, hello! We're going to be looking at our Chapter 6 review from Go Math, page 141. We are going to be looking at how to add and subtract fractions using a common denominator when our fractions are recorded with unlike denominators. So let's go ahead and begin. And we're going to begin by looking at the very first question. 5/8 plus 1/8. When I look at those, I should notice that they have unlike denominators of 8 and 4. Some friends will notice off the bat what their common denominator is, but if you're someone who does not recognize that common denominator, you can list your multiples for 4 and list your multiples for 8. So multiples for 4 are 4, 8, 12, 16. My multiples for 8 are 8 and 16. Now when you list your common multiples, some people notice 16, but in fact 16 is not our least common multiple. So we need to start at our smallest number and check. So I'm going to look at my 8s because my 8s has the least amount of multiples. I have an 8. Do I have an 8? And yes, I do. Both of them have a common multiple of 8, so I'm going to use that to create my least common denominator. So I can rewrite it going up and down if I like, or I can keep it going the same way it already is. And I want to figure out what am I going to do to go from 8s to 8s. Since 5/8 is already in 8s, I'm just going to drag it right across. And now I'm going to go from 4s to 8s. What did I do to go from 4 to 8? Very good. Times 2. What I do to my denominator, I must also do to my numerator. So when I multiply my numerator by 2 as well, I get an equivalent numerator of 2. 1/4 is equivalent to 2/8. And now I can just join together my two fractions. 5/8 and 2/8 is 7/8. So this is pretty basic. You would do the same thing when you're subtracting. Find your common denominator and then subtract. Let's go down and look at our next section. Our next section tells you to estimate. I don't want you to estimate. I just want you to solve it. So 5/12 and 7/12. 5/12 and 7/8. Again, I'm going to find my least common multiple. I have 12, 24, 36. I'm going to have 8, 16, 24. And again, look at your bigger number to compare. I have a 12. Do I have a 12? I have a 24. Do I have a 24? Yes, they both have a common multiple of 24. So I can use that least common multiple to create my least common denominator. So I'd rewrite 5/12 plus 7/8. And then again, I want them to have a denominator of 24. So I'm going to rewrite them both set with the denominator of 24. What did I do to go from 12 to 24? 12 times 2. And again, what I do to my denominator, I'm also going to do to my numerator. 5 times 2 is 10. So I've created that equivalent fraction with the denominator of 24. And we do the same thing with 7/8. I need to figure out what did I do to go from 8 to 24. 8 times 3. And again, what I do to my denominator, I'm also going to do to my numerator. So my numerator, I'm going to do 7 times 3 as well, which is 21. And again, this is addition, so add my two numerators. I get 31/24. Now this can stay as is, or I can regroup it into a mixed number, because I know that since my numerator is greater than my denominator, it's a fraction greater than 1. So I know that 31 divided by 24, it can go in one time. And when I make one whole, I'm subtracting 24/24. Because whatever your denominator is how many it takes to make a whole, all the pieces. So 31 minus 24. If I can't do it that way, I could rewrite it going vertically. I can't do 1 minus 4, so I'm going to borrow from my 3. My 3 is going to become a 2. And my 1 is going to become a 11. 11 minus 4 is 7, and then 2 minus 2 is nothing. So that means that my numerator is going to be 7, and my denominator is going to be 24. So this is an answer This is an answer as well because, again, they have equivalent values. If it was a multiple choice, this could possibly be an answer, or this could possibly be an answer. If I was looking at a multi-select, both of these could be my answer. Again, you would do the same thing next on your next question. It's just the next one is subtraction. Down here, lesson 6.4, the only thing it's telling you to do is to use your least common denominator to create equivalent fractions. So what would be my common denominator for 2 and 3? Right, my common denominator for 2 and 3 would be, again, I could list my multiples for 2, list my multiples for 3, 2, 4, 6, 8, 3, 6, 9. Your least common denominator is 6, and so you'd rewrite these with a denominator of 6, and 1/3 is equal to 6. So what did I do to go from 2 to 6? Very good, times 3. Times 3, you get 3 6. That's one answer. And then what did you do to go from 3 to 6? Times 2, times 2. That's your next answer. So you would do that for all the ones going across that way. Look at your next one. It says, again, same thing. Use your least common denominator to create an equivalent fraction. So again, you're just trying to figure out what is going to be the least common multiple that you can use to create your least common denominator. So we have a denominator of 4, a denominator of 6. We're going to list our multiples. Our multiples for 4 and our multiples for 6. So again, skip counting. 4, 8, 12, 16, 20, 6, 12, 18. Here you have a least common multiple of 12. So you'd rewrite these as equivalent fractions with denominators of 12. What did I do here to go from 4 to 12? I multiplied by 3. 1 times 3. Boom. Same thing here. What did you do to go from 6 to 12? Boom. You do that for your other questions remaining. On the back side, what do we have going on here? Oh, good. On the back side, you're actually having to perform operations. So let's look at a couple examples of what we might do. Let's look at number 2 because number 2 is a great one. It actually has you borrowing from a whole. Just so y'all know right now, I'm about to have a delicious Reese's. Oh, don't you hate it when that happens? Because you know what I have to do? I have to like lick the Reese's off that. Oh my gosh, it's fantastic. If you get to me Reese's for Halloween, or if you're worried about them being contaminated, you just give them to me. I'll take care of that. I promise you I'll take care of it for you. Okay. Oh, number 2. Oh, it's fabulous. 5 minus 2 and 4/5. How am I going to subtract 4/5 when I don't have a fraction there? Oh, I can borrow from my whole and that 5 will become a 4. How would I represent that whole in a fraction? Well, I know I need like denominators to subtract, so I'll give it a denominator of 5. And if it's 1 whole, how many 5ths would be 1 whole? Gosh, it's fantastic. That Reese's is good. Again, if you're worried about your Reese's being contaminated, Snickers too, I'll take care of that for you. Right, 5/5 is 1 whole. So now I can do 5/5 minus 4/5 equals 1/5. And then 4 minus 2 equals 2. 2 and 1/5. Let me look at another one. Oh, this is a good one. Look at number 8, because number 8 you have to do some regrouping. So 9 and 1/4 minus 2 and 5/8. First of all, I need to rewrite these with a common denominator. What's going to be that common denominator? Again, if I didn't know, I could list my multiples for 4, my multiples for 8, and find that my least common multiple is 8. So I'm going to create fractions with a common denominator of 8. This one's already in 8, so I can just drag it straight across. Here I need to figure out what am I going to do to go from 4 to 8. times 2 times 2. So now I have 2 8s minus 5 8s. Oh, that's right, I can't do 2 minus 5, so I'm going to have to go ahead and borrow from my whole. So my 9 is going to become an 8. And then what am I going to add to show that I borrowed from a whole? Very good, 8, because 8 eighths is a whole. So now I have 2 plus 8, I have 10. 10 minus 5 means that I have 5 eighths. And then 8 minus 2 means I have 6. So your answer here is 6 and 5 eighths. So again, you would be doing the same thing for all your questions, just going through, using your cubes on your work problems, making sure that you're underlining your question, boxing, circling, all that. Notice though in number 2 that you have 3 numbers that you're working with on that question. That is all for tonight. I gotta get ready for Halloween go, but again, save that candy for me. Have a great night.